Hey, welcome back everybody to my Vintage Irons channel. Today I'm going to tackle a topic that has been talked about ad nauseum, that has been overanalyzed and talked about and speculated on for several years now. And that is the fact that there has been a lot of issues and problems with flat tappet cam failures. Let me give you a little background on my experience has been and what we've done in the shop and on the dyno to kind of try to evaluate some of this. The first issue that we have to deal with is what you'll hear a lot is people will say, oh, well, the flat tappet cams they're made in China and the metal's no good. Okay, that's something that needs to be addressed. A friend of mine has a hardness tester. I mean, you can watch the hardness test videos online that will verify what I'm going to say. So we took his Rockwell hardness tester and we got every camshaft we could get our hands on. We got Lunati, Comp, Engine Pro, Howard's, Isky. We had a Cam Dynamics cam. We had a bunch of all the major manufacturers. We had their cams. We tested them on the hardness tester. The fact of the matter is, you guys, is that none of those cams were soft. So then we got our hands on every flat tappet lifter that we could test. We tested some that were new. We tested some that were used. We tested some that have gone flat completely, just wiped out. We didn't find a single lifter or a single cam from any manufacturer across the board that had a hardness problem. So, you know, you're not going to convince me. You'll hear people say, oh, it's just this Chinese junk that's coming in. You're not going to convince me that the hardness is a factor. You'd have to prove that to me. You'd have to actually show me on the hardness tester where there's an issue with the metallurgy. We haven't seen that. It hasn't materialized. We tested probably 30 or 40 cams from all those manufacturers for different years, older ones, newer ones, flat tappets, rollers. Honestly, the flat tappets that we checked had basically the same hardness values as the rollers. So we're like, okay, so the hardness, you know, we could just take that off the table for now, because I do not believe that that is the issue. One of the things that we ran into, though, we did find some lifters, and now when it comes to lifters, keep in mind, many manufacturers are buying and reboxing their lifters. You know, this, people don't understand, you know, that, well, I bought Comp lifters, or I bought Howard's lifters, or I bought new Lunati lifters. There's only a few major lifter manufacturers on the planet that are supplying these lifters. Again, keep in mind, the lifters were not soft. We didn't find any soft lifters, and we checked hundreds of them from every possible source we could get our hands on. And multiple manufacturers, Ford, Mopar, Chevy, most of them were flat tappets. And like I said, we checked some rollers. The rollers were in the same ballpark of hardness as the flat tappets. We don't believe that that is the issue. I don't believe it is. The one thing we did find, though, is that the crown on the lifters, there was a big variation from one lifter to the next, as far as, because the bottom of the flat tappet lifter is manufactured in a spherical, slightly spherical design, and that's what promotes rotation. It also is offset from the center of the lobe. And then the lobes are tapered. So there's a spherical bottom, and you can check that with a small straight edge. There is also lobe taper that you can measure with a micrometer from one side of the lobe to the other. And we usually see on cams that don't have any problems, you should have 1.5 to 3/1000 lobe taper, somewhere in there. We did find camshafts that had the lobe taper was non-existent, and it wasn't just one manufacturer. It was several major manufacturers where the manufacturing process of the lobe grinding was a problem. We also found lifters that weren't rotating. I had one particular experience. In my shop, I personally lost 5 or 6 engines in a period of about 6 to 8 months. One of them, the camshaft went flat on the run stand during the break-in. I got 7 minutes into the break-in and the thing just started rattling. It just shredded a lobe off the cam. Now keep in mind, you know, I know some of you say, well, you know, there is the crowd out there that's going to say, you didn't use the right oil or you didn't do the break-in process properly. I personally have been breaking in flat tappet cams for almost 30 years. And in fact, in the early days of camshaft break-in, we didn't need special oil because the oil off the shelf had the additive in it. It had ZDDP in the oil. The ZDDP was removed from the oil in the mid-90s by a mandate from the manufacturer, from the EPA, because the EPA approached the manufacturers and they told Ford and GM and Chrysler and these manufacturers, listen, if you're going to sell a car in North America, you have to warranty the catalytic converter for 100,000 miles. And the manufacturers fired back and said, that's impossible, we can't do that. And the EPA said, well, what do you mean? Why can't you do it? Why can't you build a cat that can last that long? And basically they said, well, listen, there's elements in the engine oil that is destroying the catalytic converters. One of the main additives that was damaging or shortening the life of the converters was the ZDDP content. I'm not going to get into the chemical name and all the makeup of that. That's basically the additive that makes the flat tappet cams live. When you put in a break-in oil, you're putting in an oil that has high ZDDP content. A lot of people refer to it as zinc. It's actually not the zinc that is protecting the cam, but you know, you can research that and look into it. It's been dubbed high zinc oil. And in reality, that's a bit of a myth, but the fact of the matter is that the ZDDP content is, it actually, what it does is it embeds itself into the cam lobe and creates a sacrificial layer on the flat tappet lobe that protects it. When you take that away, you don't have that ZDDP embedding itself in the cam lobe and creating a protection for that lobe, and it wipes out the cam. Now, in the old days, I mean, oh man, I mean, there was so many engines that I built when I first started in this business. And keep in mind, you know, in my younger days, I thought I knew what I was doing, but now I look back and I was like, hey, really, there's a lot of stuff I didn't know. There's a lot of stuff I didn't have a clue about. There's probably still things I don't know, but the reality is, you know, there's the old saying, the more I learn, the more I realize the less I know. So anyway, there was engines that I put flat tappet cams in back in the early days in the machine shop business. I never revved them up. I never did any kind of break-in with them. We used oil off the shelf. Of course, it had ZDDP content in it from the factory or from the oil manufacturers because everything was flat tappet. But we never revved it up to 2,000 RPMs. We did, according by today's break-in standards, we did everything wrong. Now, keep in mind, the metallurgy was different back then. I think it was more forgiving because there were so many engines that we built that we didn't really follow all the procedures that we do now. We ran them with real heavy dual springs. We didn't rev them up, and man, they live no problems. So there is some element of metallurgy. So let me clarify that by saying today, if you put a camshaft in without break-in oil and without getting the RPMs up to 2,000 to get the oil up there, you'd probably have a flat cam for sure. We started having in the mid 80s, I'd say early 80s, I did an engine and it wiped out the cam. And a journeyman machinist friend of mine said, did you rev it up? Did you do the break-in properly? You know, probably about 1983, 84 is when I first heard the concept of revving the engine up to break it in. And I said, no, I didn't do that. He says, oh, you got to get the RPMs up. So the next one I did, I followed his procedures. I revved it up to 2,000 RPMs for the first 20, 30 minutes. No problem. Cam lived, no issues. So I started doing all of them like that from then on, the break-in procedure. no issues. Fast forward to the mid 2000s, 2007, 2008, somewhere in there. Might have been 2010, I'm not sure if I remember exactly the year, but it was in the mid to later 2000s, started having cams going flat again. And that is when we discovered, hey, the EPA has mandated. Now keep in mind that people say, oh, it was in 2008 that the EPA mandated this. The EPA did not mandate the removal of the ZDDP from all the oil. They did it gradually. So there was some oils that had it, there was some that didn't. I know that for a number of years, diesel oils had zinc in it. I'll hear guys say now, oh, just use a diesel oil. It has zinc. It actually doesn't anymore. They've actually removed all the zinc because of the particulate filters and the way that the diesel emissions is today. The diesel oils, if you try to put that in and thinking that it has ZDDP in it, you're making a big mistake because it doesn't have it. At least it doesn't have nearly as much. That's not a thing you can do. You can't just run diesel oil. You do that, you're probably going to have a flat cam. The mid to late 2000s, we started having these cam failures again. And then we went through that whole ordeal. I think I lost 10 cams out of my shop. That was when everybody got the understanding and the revelation that the EPA had actually completely full-blown removed ZDDP from oil off the shelf. Kind of a backstory to this, I have some friends that work in NASCAR, specifically for Roush Yates. In 2012, I believe, the NASCAR switched over to roller cams and fuel injection. Long overdue, right? Hard to believe that up to 2012 they were using carburetors and flat tappet cams. That's just, but anyway. I talked to an insider on this and I said, oh, you guys probably, you probably come updating to the 20th century, huh? Putting roller cams in. And his response was, the only reason we went to roller cams is because we've had so many flat tappet failures. And he said, that's unofficial. We're not going to admit that that's the reason. But he said the reality is we've had major camshaft failures even before a practice run is over. They've lost, you know, $150,000 engine. The teams really pushed the engine builders, Roush Yates, the Wood Brothers, all of those guys. They really pushed for rollers because they're like, we can't have engines being wiped out left and right like this because of these flat tappets. So they went to roller and all their problems went away. And just let me clarify, like when I build engines now, I will not build a flat tappet cam engine. I won't. And so I know I'm going to get criticized for that and say, well, you know, if you check the hardness and you make sure that the taper on the lobe is right and you inspect the cam and you spend all this time and you do just the right spring pressure, you know what? I don't want to deal with all that nonsense. To me, that's just a waste of time when a roller is a much better cam anyway. I've had customers say, well, I can't afford a roller. And I go, well, can you afford to do your engine twice? Because if you lose a flat tappet, because of what we're seeing with poor manufacturing standards today, can you afford to do your motor over again? Because if you lose a flat tappet lobe, it fills your engine with oil, or with metal rather, and you basically have to rebuild the engine again. And I know this is a hard thing to take. I have customers and friends that, I mean, they've already bought all their parts. They have their flat tappet cam. They have their build all planned out. And it's a dilemma because they call or they email me or they send me a message and they're like, what should I do? I've got all this money invested in this engine, or they've got the engine together and they're ready to fire it up. I've got all this money invested in this engine, and here now I'm getting scared. I'm getting gun shy because of all of the horror stories I'm hearing about flat tappets. The simple answer and the short answer to that is, regardless of where you're at, take a hit, get rid of the flat tappet cam. So here's another issue, guys, and this is another thing that really needs to be addressed, I think, and that is the manufacturers have not used flat tappet cams for a couple of decades now. When the manufacturers were using flat tappets across the board in everything, 70s, 80s, early 80s, they had put demands on the lifter and the cam manufacturers, and they said, listen, this cam's got to work. The standards of your manufacturing have to be really high. We cannot sell brand new vehicles that don't run for 100, 150, 200,000 miles. They have to be able to do this. When the manufacturers went away from widespread use of flat tappet cams, the demand for quality of manufacture went away. Cam manufacturers and the lifter manufacturers, for that matter, there wasn't this stringent demand from big money manufacturers, huge money, saying you will hold these standards, you will build a product that's going to last. That went away. So now the only people really using flat tappet cams are sportsmen and aftermarket and certain classes of racing and so forth. Well, that's a much, much smaller market than Chrysler and GM and Ford. And so the standards, this is just my theory, but this is what I believe happened. The standards that were held, that the cam manufacturers and the lifter manufacturers were held to by the manufacturers, went away. And they're like, oh, well, you know, we don't have to do all the quality control that we did. We don't have to, you know, look how much it's costing us. We're not making near as much money because we're not getting money from Chrysler and Ford and GM or Toyota or whoever. So we're gonna shortcut some of our quality control and some of our manufacturing standards because, yeah, we're not making the money. We don't have the money for that in the budget. We're not selling near as many cams, and also the aftermarket, they're not really demanding, and even if they do demand it, they don't have the influence and the big manufacturing money to hold us to account. I mean, if we have a flat cam go flat here and there, what are you really going to do? I mean, I've tried to get warranty on flat cams. It's like pulling teeth. It's nearly impossible to get them to warranty it. I had one that I sent back to comp, and it took them a year. Well, if you're running a machine shop business or you're building an engine and you have to wait a year for a warranty, you might as well just write that off. And the thing is, the cam manufacturers know that. They know that they can outweight you. And it sounds like a really terrible thing or position for them to take, but it's business. So this is a really big issue. My advice to you is, well, first of all, my conclusion after all that I have studied and looked into and researched and tested is that it's a manufacturing problem with the components. It is not, and it's also a combination of improper break-in. I mean, there's guys, number one, if you have too much spring pressure on a flat tappet, you know, cams have become a lot more aggressive in you know, the modern era now, later model stuff. The spring pressures have become heavier. Listen, flat tappet camshafts have a very, very real restriction on spring pressure. In other words, roller cams, like if you run a solid roller, basically you can run unlimited spring pressure. That's why all the monster engines and the drag race motors and you know, engines that make real big power, they run solid rollers because basically you can have as much spring pressure as you want. Flat tappet camshafts do not do well with more than probably about 300 pounds of total spring pressure. It'll wipe the lobe out. So that is another possibility or another factor. You buy cylinder heads and they're set up with roller cam springs. They have a set of springs on them that have too much spring pressure for a flat tappet. Guys slap them on, put a flat tappet in, wipes out the cam. The other issue is the oil. Guys, I've seen people post, oh, that whole ZDDP zinc, copper, phosphorus additive is a myth. You don't need that. Well, that's not true. You do need it, and you'll most likely wipe out your cam if you don't use a good break-in oil. Another issue is guys will buy the zinc additive, the ZDDP additive, and put it in regular oil. You absolutely cannot do that. The problem with, they'll just go buy Valvoline or Pennzoil or whatever off the shelf, the modern oil today, that has a lot of detergent in it. Now, detergent-based oils, you do need a detergent in your oil that keeps the sludge from building in your pan. In the old days, we had non-detergent oil, and it was very common to see pans full of sludge after, high mileage. The detergent that they put in the oils today helps to keep the inside of the engine clean, and that's a good thing. The problem is during the break-in process with ZDDP, if you just put that additive in with a detergent-based oil, is the detergent literally washes the ZDDP additive off of the lobes, and it doesn't have a chance to embed itself or become impregnated in that lobe, and you got a cam failure. And people are scratching their heads and they're like, I put zinc additive, what happened? Well, if you're going to use zinc additive, you have to use a non-detergent oil. That's a big issue. The break-in oils are non-detergent. They don't have that in there. Lucas has a good one. Driven used to be Joe Gibbs, very good. There's a lot of good break-in oils out there now, but you'll notice that those are all non-detergent oils because they want that ZDDP to have a chance to embed and impregnate that cam lobe to protect it. So there are issues. Other issues is, guys, I've seen videos on YouTube where guys, they got a new flat tappet cam in and they start the motor and let it idle. You absolutely cannot do that, not even for a few seconds, but they'll let it idle and they'll adjust, the timing, and they'll make carb adjustments. A brand new cam, it's idling. You need to get the RPMs up on that engine to 2,000 RPMs immediately, and it needs to stay there. It's okay to shut it off if it gets hot or you have an issue, but don't let it sit there and idle. That is going to wipe out this cam, or there's a good chance that it is. So there are, it's not just one problem. You have the issue of disinformation, where guys don't understand the proper break-in procedure. They don't understand what oil they should be using, or how they deal with additives, or what kind of additive, or what kind of oil to use with additives, and how much spring pressure they should have. There's all of that. One of the things I did is I bought low ratio rocker arms for my break-in stand. The small block Chevrolet has a 1.5 ratio, so it's 1.5 times. I bought a rocker arm ratio that had a 1-to-1 ratio. It's just a break-in rocker arm. It's no good for performance, but it literally transfers the load lift to the valve, so the valve is only lifting 300 thousandths or 280 thousandths, whatever the load lift is, and that puts much less spring pressure and stress on the cam. You don't need big spring pressure at 2,000 RPMs for break-in. You don't. Especially with no load on the engine during break-in. So there's a lot of issues as far as proper break-in procedure and proper oil goes, but the fact of the matter is that we've done all that, and it had for many years it was effective. We had no problems, and all of a sudden now here in the last probably 5-6 years now, cams are just randomly going flat for no reason. Well, bottom line, it's poor manufacturing. It's very lax standards that the manufacturers are being held to. And because of that, I don't see this problem correcting itself anytime soon. I don't. The manufacturers there's enough people buying flat tappet cams that they're making all kinds of money. Their quality control standards, I don't see them improving. And or if they do improve, they're going to have a track record of proven reliability. Proven. Right now they have a track record of failure. I've eaten so many jobs from customers because the cam went flat that we installed. It's costing too much money. I can't afford that anymore. Some companies, it almost bankrupts them. It almost bankrupted me. I have completely turned my back on flat tappets because of this reason. If you're gonna build an engine, my advice is go roller. Well, I can't afford it. Well, you need to think about this ahead of time, and you need to budget in a roller cam. Budget in a roller before you start. Just get that into your thinking that, you know, if I do this, if I build this, I'm gonna have to save money or set aside money or allocate money for a roller. If you can't afford a roller, how can you afford to do a flat tappet motor 2 or 3 times? I had a buddy that 3 times in a row, he lost camshafts in his flat tappet, and he finally went roller, and he said, man, if I would have just went roller in the first place, I would have saved like $2 grand. So that's my take on it, and that's where I stand with it. If you have anything to add to this, you can add to the comments below. Try to keep it friendly, right? I know I always get the guy that's like, oh, break-in's a myth. That's all a myth. You don't know what you're doing. Well, I've been machine shop, automotive engine builder for 32 years and was very, 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 very successful with flat tappets for many, many years. Nothing changed except the cams. The cams changed. Go roller or don't build it. That's my advice. Thanks for watching. I appreciate it. I will talk to you very soon.